Okay, it seems that the Zoom had a bad day and it froze. So what I've done is I've made a little PowerPoint to kind of make sure that you've got the directions you need for your homework. So I'm going to kind of share you that PowerPoint and talk through it with you to make sure that you're clear. All right, so let's see if it's gonna have a good day. All right, looks like it's a good day. So maybe Zoom's happy again. All right, I want to talk about binomial probabilities for just a minute. This won't take super long. It's kind of a review of what we did in class, plus one extra thing I need everybody to look at because we're going to talk about it next time, but we're going to talk about it pretty quickly. All right, so do we understand that on binomial probabilities, you can only have two categories? All right, but that happens a lot. You know, you live or you die, you pass or you fail. You flip the coin and get heads or you get tails. You know, either you're left-handed or you're right-handed. So, and then the probability's got to be the same throughout the problem. So like we talked about, you have to have independent things happening. So your chance of being right on question 1, your chance of being right on question 8, and your chance of being right on question 11 have all got to be the same. It can't change in the middle of the problem. If it does, then you can work it, but you can't work it using binomial, okay? Now, the thing seemed to have frozen when I was given the calculator instructions. So if the formula that we went over in class, that binomial formula, is programmed into your machine. So rather than you doing it by hand, you can get the calculator to do all the work. But I needed you to see what the calculator was doing. So that's the reason we went through all that work of doing it by hand. So you can see what the calculator's doing. That way, if you get on a test and you forget how to use the calculator, you can go back and do it by hand if you need to. Okay, because the calculator instructions are not on the formula sheet. So that means you have to remember these calculator instructions if you want to use the calculator. So to get to the binomial distribution, you go to second and you punch that Bayes key. All right, so you've got to find that Bayes key because right above Bayes it says distribution, D-I-S-T-R-I-B or something, some little acronym, some little abbreviation of distribution. So to get there, you had to hit second Bayes. So when you do, a whole menu of stuff's going to pop up. It starts with normal PDF, normal CDF. I don't want any of that. So there's a down arrow. So if you take the arrow key on your calculator and start punching down, it starts moving down to some things you can't see yet. You are looking for either binomial PDF or binomial CDF. So that's further down on your list. All right. Sometimes you use binomial PDF and sometimes you use binomial CDF. Now, when do you use the P? You use the P when there is one number next to X, just one number. You use the binomial CDF when you've got a list next to X. But this is crucial, that list has to start with 0. If it's a list that doesn't start with 0, you cannot use this key. We're going to talk about that at the end. All right. So one number next to X, you can pick binomial PDF. A list of numbers that start with 0 next to X, use the binomial CDF. And this order is crucial. You have to type in the N first and then the comma. And like I said, the comma is above the 7 on your calculator. Then you type in your P value and you type another comma in, and then you type in your X value. And then you close that parenthesis. That's above your 9 key. And then you hit enter. Now, if you've got some of the newer models, instead of the parenthesis opening, it starts asking you questions like number of trials. That would be your N. And then it asks you for P and X. And then you have to go down and hit paste. And when you hit paste, then suddenly this shows up on your screen. All right, but N has to come first, a comma. P has to come second, a comma. N has to come last, and close the parenthesis. Now, what if you've got a whole list of numbers? Well, it's still the order NPX, but you got a bunch of things next to X. It wants the biggest one. All right. So we're going to go work a couple to make sure that we're good. So let me clear these drawings and then go to the next slide. So let's look at a couple of problems worked out. This is not one we worked in class, but it's the same sort of one we worked in class. 10% of people are left-handed. So in a room of 25 people, find the following probabilities that exactly 3 are left-handed. Now you got to put a P and put what you're looking for in that parenthesis. Now, what I said in class was, even if you're not doing the formula by hand, I better see N, X, P, and Q written on your paper like this, or you won't get any partial credit. All right? So N is always your total. So see, there were 25 people in the room, so N is 25. Remember, X is the number in the parenthesis with the modifiers. Exactly 3. Well, how many is exactly 3? Just 3. All right, P is the probability of what's in the of the category. Now, I don't care about this number. I don't care anything about that number. I'm just looking at this category. What's the probability somebody's left-handed? Well, according to the problem, it's 10%. And 10% as a decimal is 0.10. You can put, if you'd rather put 0.10 instead of putting 0.1, you can. 10 hundredths is the same thing as 1/10. Those are the same number. Well, how do you know Q when you know P? You do 1 minus P. So 1 minus 1/10 is 9/10. Okay? So once I get these set up, I just go to my machine. So I go to second Bayes. I scroll down. Now, how do I know whether to pick binomial PDF or binomial CDF? Do you see that you've got one number next to X? So that's how I know to pick the P one. So I type in the N first, so I type in 25 and a comma. I type in my P value next, so I type in 0.1 and a comma. I type in my X value, 3, and I close the parenthesis. When I hit enter, this number comes up on the machine. I just rounded it. So I want that 4 places, 3 or 4 places, okay? So that's rounded. That's why I've got approximately equal to. All right, now look at this one. What's the probability that at most 20 are right-handed? I changed the question. So I put a P, at most 20 are right-handed. So my N is still 25, that's still my total. But now it says at most 20. At most 20 is not just the number 20. And at most 20 doesn't mean more than 20. If I say that bridge holds at most 2,000 pounds, that means it'll hold 2,000 or less, okay? So at most 20 literally means, what does it mean? It means 0 or 1 or 2 all the way to or 20 are right-handed. So that's why next to X I have 0 or 1 or 2 or 3 or ... all the way to 20. Now, P's got to be the category in the parenthesis. We'll say I changed the category on you. The category in the parenthesis is right-handed. So P has to go with being right-handed now. See, up here in the parenthesis said left-handed. So P went with left-handed. So P is the probability of the category in the parenthesis. So if 10% are left-handed, that means the rest 90% are right-handed. So that's where I got the 0.9, the 90%. And then Q is 1 minus P. So I'm back to the 0.1. So then I go to binomial C. Now, why did I pick binomial C? Because there's more than one number. There's a list, and the list starts with 0. So the PDF goes with one number. The binomial CDF goes with a list, but the list has to start with 0. So I typed it in. N, P. Now remember what I said. This has to be your biggest X when you've got the C key, because you got a bunch of numbers, but it's going to start with 0. It's just where to stop. Okay. So when I type all that in and hit enter, this came up and I rounded off. Okay. So that's nothing new, except it does tell you what order to put them in your calculator and when you pick the binomial P and when you pick the binomial C. Now, what I'm going over next is new for everybody, so pay close attention. All right, look at this one. What's the probability that at least one is left-handed? Now, like I said before, what does at least one literally mean? It doesn't mean less than one. If you have to have at least $10 to get into the show, you can walk in with a 20, but you can't walk in with a 5. So at least does not mean less than. At least means this is the minimum. So it means this number or bigger. So you better write it out or you're going to get lost. So at least one means 1 or 2 or 3 or 4 all the way to or 25 or left-handed. Then you do your P, your X, your N, and your Q. N's my total. Remember, my total was 25. So X are the numbers in the parentheses. So 1 or 2 or 3 all the way to or 25. All right, which category is in the parentheses? Left-handed. So P has to go with left-handed. So you can scroll back over here and remember that 10% were left-handed. So P was 10% as a decimal, or 0.1. And then Q, remember, is 1 minus P. So that's where I got the 0.9. Now, once I get all of these filled in, then I'm ready to go grab my formula. Well, now, why can't I grab that binomial PDF key? Because I've got more than one number. It's reserved for one number, so it's out. Why can't I use the binomial CDF key? Because I got a list, but my list does not start with 0. So I'm stuck, okay? So that binomial CDF is with a list, but the list has to start with 0. Well, I've got two choices at this point. Here's what I could do. I could use the binomial PDF key with 1. So I'd have N would be 25, comma, my P is 0.1, comma, my X is 1. And I could get an answer and write it down. Then I could start over and do binomial PDF and do it with 2. So now I got to do 25 is my total, my P is 0.1, my X is 2, and get an answer. And then I could start using 3. So I could use this formula, this button on my machine, 25 times and get 25 different answers. Now, what do you do with OR probabilities? Don't you add? So I could use the binomial PDF key 25 times and add all 25 answers up. But what I said was, that is too much trouble. No, thank you. Now, somebody on their test is going to do it that way. And I'm just going to go salute. You can do it that way if you want to. But I'm not going to do it that way. I don't have time to do it that way. So when you think to yourself, that's too much trouble, here's what I want to pop into your mind. I could do 1 minus the complement. Now remember what the complement is. The complement's everything but that thing. Okay? So think about, if 25 people are left-handed, if 25 people are in the class, how many could be left-handed? Well, 0 could be left-handed, 1 could be left-handed, 2 could be left-handed, 3, all the way up to 25. Remember, that's the sample space. So the complement is everything but these. So if I take all of that out, the only thing left is my complement. So the only thing missing is 0. So the complement of at least 1 is 0. And it's going to be the same, or same category, left-handed. So what I'm going to do is, I'm going to go work this problem I boxed in red, because it's way easier. Because look what happens. My total is 25. Remember, X comes out of the parenthesis. Well, now there's only one thing in the parenthesis, 0. And P is the category. It's got nothing to do with the 0. P is your chance of being left-handed, which remember was 10% or 0.10. And then Q is 1 minus that 0.1, so I get 0.9. So now I can do binomial PDF 1 time, because I've only got one number next to my X. So there's my N, there's my P, there's my X. I get this number. But I'm not finished. I have to subtract that number from 1, and this is my final answer. Okay? So if you've got to do something a bunch of times and add them up and you don't want to, what you could do instead is 1 minus the probability of the complement. All right, let me show you one more real quick. All right, look at this one. What's the probability that at least 10 are right-handed? Now remember what I said. What does at least 10 mean? It doesn't mean less than, it means that number or more. So at least 10 literally means 10 or 11 or 12 or 13 all the way to or 25 are right-handed. So we think it's binomial. Either you're right-handed or you're left-handed, and your chance of being left-handed is always 10% according to this problem. So I go fill in my N, my X, my P, and my Q. So my total is 25. Remember, my X are the numbers in the parentheses, so 10 or 11 all the way to or 25. P's got to be the category in the parenthesis, which is right-handed. So if 10% are left-handed, 90%, the rest have to be right-handed. So that's where I got the 0.9. And then 1 minus P gives me Q. So what I could do is what we said before. I could use that binomial PDFQ with 10 and get the answer. And then start over and do that binomial PDFQ with 11 and get the answer. And then start over. I could do it all 16 times and get all those answers and add them up. But I'm not doing that. That's too much trouble. So when I think that's too much trouble, I'm going to do 1 minus the probability of the complement. Remember, how do you do the complement? You think of all of your sample space and you delete this from it. Now remember, that sample space was 0 or 1 might be left-handed, 2 might be left-handed, 3 might be left-handed, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, it would be all the way to 25. That's how many people might be left-handed in a room of 25 people. So if I take out from 10 all the way up to 25, what's left is the complement. So that's why it goes 0 or 1 or 2 and stops at 9, because that's what happened when I delete these numbers from the sample space. The remainder is the complement, and it's the same category, or right-handed. I'd rather work this problem. Now look at why I'd rather work this problem. My total is 25, that's the same, but my X is different. Now it's 0 to 9. My P is still the category right-handed, so it's still 0.9, and my Q is still 0.1. Why do I like this list better than this list? Because this list starts with 0. And when I've got a list that starts with 0, I can use the binomial CDF key one time and be finished with this part. So there's my N, there's my P, and remember, it's your biggest X when you got the C key. So there's my biggest X. And I got this long number. Now look, that's what I'm talking about. I can't round off to 3 or 4 places because that would round off to 0. So I had to go all the way out to here. But if you do 1 minus the complement, when you get this answer, remember, you're not finished. You got to take that answer and you got to subtract it from 1. So 1 minus that number is that number. That's my final answer. So if you think something is too much trouble, if you don't want to work something like a bunch of times and add them up, you think I could do 1 minus the probability of the complement. Okay? Hopefully that figures out what you got confused on when it froze on Zoom. So sorry about that, but I can't control what Zoom's doing. But you should be able to do your homework now. If you have a question, email me. If you need an appointment, come see me. All right? Hope you have a great day.